Friends, today we are going to discuss 10 questions from electromagnetic waves. It is a highly mathematical session, therefore you should listen carefully. Actually, electromagnetic theory was proposed by Maxwell for light. Light has different theories. First, Newton's corpuscular theory, Huygens wave theory, then modified wave theory. Huygens wave theory was modified by Fresnel, then Maxwell's electromagnetic theory, then Planck's quantum theory, then Einstein introduced dual nature idea to light also. That is, electromagnetic theory is one of the theories about the nature of light, and Maxwell proposed electromagnetic theory to light. Today we will discuss some questions about these electromagnetic waves and electromagnetic theory. The first question is, for an EM wave, that's for an electromagnetic wave, the general wave equation becomes, I will discuss in detail. If E is the electric field and H is the magnetic field in ampere per meter, here magnetic field can be expressed in terms of H or B. If it is represented as H, it will be in ampere per meter, and if it is represented as B, it will be in Tesla or Weber per meter square. Generally, I'll give some ideas about the equations. Now, all the progressive wave means a wave in which energy transfer takes place along a particular direction. All the progressive waves should satisfy a condition called general wave equation, that is d square y by dx square equal to 1 by v square d square y by dt square. I'll write it. D square y by dx square equal to 1 by v square d square y by dt square. This is the general wave equation to be satisfied by all the progressive waves. Here y is the variable, v is the wave velocity, that is the velocity with which the wave is advancing in a particular direction. V is the wave velocity. Then electromagnetic wave is also an example for a progressive wave. Therefore, for an electromagnetic wave, the general wave equation becomes d square E by, instead of y, either electric field or magnetic field becomes the variable. If E is the variable, d square E by dx square equal to mu epsilon d square E by dt square, or d square H by dx square equal to mu epsilon d square H by dt square. Here, either the electric field or the magnetic field becomes the variable. These two are the general wave equations for an electromagnetic wave. Then, in the given equation, instead of 1 by v square, we have mu epsilon. That is, 1 by v square equal to mu epsilon. Here v is the wave velocity, that is the velocity with which the wave is advancing in a particular direction. For an electromagnetic wave, usually this wave velocity will be represented as c. And for the medium air, light has a velocity 3 into 10 raised to 8 meter per second in air or vacuum. It's one of the major statements of the electromagnetic theory. Now, 1 by v square equal to mu epsilon, therefore v equal to 1 by root of mu epsilon, which can be represented as c generally. Once again, I'll repeat everything. For an EM wave, the general wave equation becomes d square E by dx square equal to mu epsilon d square E by dt square, where capital E is the electric field intensity. Or d square H by dx square equal to mu epsilon d square H by dt square, where H is the magnetic field in ampere per meter, not in Tesla. Then Instead of the wave velocity v, here we have 1 by root of mu epsilon equal to c. Therefore, the velocity of an electromagnetic wave is given by 1 by root of mu epsilon. For air, mu becomes mu 0, epsilon becomes epsilon 0. Then, for light, the wave velocity or speed of light is given by 1 by root of mu 0 epsilon 0, which gives the value 3 into 10 raised to 8 meter per second. Now, we'll go to the question. Here the question is, for an EM wave, the general wave equation becomes, let us discuss one by one the choices. The first choice, d square E by dx square equal to mu epsilon d square E by dt square. That's a correct choice. Then second one, d square h by dx square equal to mu epsilon d square h by dt square. That's also correct. The first one, electric field is the variable. Second one, magnetic field is the variable. Third one is wrong. Then the correct answer is D, that is A and B are correct. Therefore, for the first question, the correct choice is D. Second question is about the velocity of electromagnetic wave. The question is, the velocity of an electromagnetic wave in any medium is given by, we have already discussed from the general wave equation, 1 by v square equal to mu epsilon, then v equal to 1 by root of mu epsilon. Then the speed of light or speed of an electromagnetic wave generally is given by c. Wave velocity is given by c. C equal to 1 by root of mu epsilon. In the first question, in the discussion of the first question, it is already mentioned. Therefore, the speed of electromagnetic wave is generally given by c equal to 1 by root of mu epsilon. Here, therefore, the correct choice is C equal to 1 by root of mu epsilon. Here, root of mu r epsilon. Mu r is relative permeability. It is different from mu. Then mu 0 permeability of vacuum or air or free space. Epsilon 0 permittivity of vacuum or air or free space. D choice becomes correct only for air or vacuum. Here the question is general equation, about the general equation. Generally, C equal to 1 by root of mu epsilon, which is applicable to all media. Therefore, the correct choice is B. B is the correct answer. The third question is about the term refractive index. Actually, the definition of refractive index, most elementary definition of refractive index is refractive index equal to the ratio of the speed of light in air to that in the given medium. Means refractive index n equal to speed of light in air divided by speed of light in the given medium. If n is the refractive index, its basic definition is speed of light in air divided by speed of light in the given medium gives the refractive index of the medium with respect to air. Now, speed of light in air by electromagnetic, we have 1 by root of mu 0 epsilon 0. And speed of light in the given medium is 1 by root of mu r mu 0 epsilon r epsilon 0, general equation. Then refractive index of the medium is the ratio of speed of light in air to the speed of light in the given medium. That is speed of light in air 1 by root of mu 0 epsilon 0 divided by speed of light in the given medium 1 by root of mu r mu 0 epsilon r epsilon 0. Then this ratio will give root of mu r epsilon r. Therefore, the refractive index of a solid medium is generally given by n equal to root of mu r epsilon r. Then the correct choice becomes C. Root of mu r epsilon r gives the refractive index of a solid medium generally. Now, we are going to question number 4. The question is the dimensional formula of root of mu by epsilon. Mu is the magnetic permeability, epsilon is the electric permittivity. മ്യൂവിൻ്റെയും എപ്സിലൻ്റെയും ഡയമെൻഷണൽ ഫോർമുല കണ്ട് ഡിവൈഡ് ചെയ്ത് റൂട്ട് എടുക്കാം. പക്ഷേ ഇവിടെ അത്രയൊന്നും ആവശ്യമില്ല. വി ഹാവ് another. If the theory is thorough, we have very shortcut method here. Now, I will discuss the corresponding theory. For an electromagnetic wave, when an electromagnetic wave is advancing through a medium, the ratio E by H, electric field to magnetic field, E by H will be equal to root of mu by epsilon, is called characteristic impedance of a non-conducting medium. I'll write it. Electric field to magnetic field ratio E by H equal to root of mu by epsilon equal to eta is called characteristic impedance of a non-conducting medium, and for air its value is 377 ohm. Its value is 377 ohm. Its unit is ohm. Term is characteristic impedance, means it will have the dimensions of resistance. Therefore, E by H equal to root of mu by epsilon equal to eta will have the dimensional formula of electrical resistance. That is ml square t raised to minus 3 I raised to minus 2. Let us check the choices one by one. First choice is ml square t raised to minus 3 I raised to 2. It is wrong. Second one, ml square t raised to minus 3 I raised to minus 2. This is the dimensional formula of resistance. For current, you can write either I or A. Both are correct. Here, the dimensional formula of resistance is ml square t raised to minus 3 I raised to minus 2. Therefore, B choice is the correct answer. Next question is about Maxwell's electromagnetic equations. Maxwell selected 4 standard equations as electromagnetic equations, which is to be satisfied by all the electromagnetic waves. Then, according to Maxwell, an electromagnetic wave contains, it has electric field and magnetic field in 2 perpendicular directions, and its propagation direction, propagation of the wave, the propagation direction will be perpendicular to both the electric and magnetic fields. If electric field is along the x direction, magnetic field is along the y direction, then the velocity vector, the propagation direction will be along z direction. That's perpendicular to both the electric and magnetic fields. And Maxwell selected some equations also. First one is Faraday's law of electromagnetic induction. That is, the magnitude of the induced EMF is proportional to the rate of change of flux linked with the circuit. This is Faraday's law of electromagnetic induction, and that is one of Maxwell's electromagnetic equations. Then, according to Ampere's circuital theorem, closed integral B dot dl or line integral of magnetic field will be equal to product of the permeability of the medium and the current enclosed. Maxwell made some corrections or extensions for Ampere's circuital theorem. Then, Gauss's flux theorem of electrostatics, total electric flux over a closed surface will be equal to 1 by epsilon times the charge enclosed. Similarly, Gauss's law of magnetism, total magnetic flux over a closed surface will be 0. These 4 equations were selected by Maxwell as Maxwell's electromagnetic inductions. Out of the 4 equations for Ampere's circuital theorem, he made some modifications also. I'll write all the Maxwell's electromagnetic equations. First one, closed integral of E dot dl equal to minus of B dot dot dA. B dot means d by dt of B. Second one is closed integral of H dot dl equal to J plus D dot dA. Third one is closed integral of d dot dA equal to integral of rho dV. Fourth one is closed integral of B dot dA equal to 0. These are all in the integral forms. I will write down all the equations in the differential form also, which is more familiar to you. Anyway, B dot means d by dt of B. H means magnetic field in ampere per meter. J means current density, current per unit area, I by A. Capital D, electric flux density, epsilon E. Epsilon E is taken as capital D, and capital D is called electric flux density. D dot means d by dt of D. Then rho is volume density of charge, charge per unit volume. Now I will explain one by one. First one is actually Faraday's law of electromagnetic induction. Faraday's law of electromagnetic induction in the integral form. In the common form it becomes N d phi by dt equal to the magnitude of the induced EMF. The magnitude of the induced EMF is proportional to the rate of change of flux linked with the circuit. That is Faraday's law of electromagnetic induction. Its integral form is given as the first equation. Then, for the second equation, Ampere's circuital theorem is slightly modified by Maxwell. Ampere's circuital theorem is closed integral B dot dl, that is line integral of magnetic field, is equal to the product of the permeability of the medium and the current enclosed. That is closed integral B dot dl equal to mu I. If mu is taken here, B by mu becomes H, field in ampere per meter. Then H dot dl equal to I. For this equation, Maxwell put a correction factor, the second one. J dot dA means I. Then it becomes Ampere's circuital theorem. Second term is the correction factor proposed by Maxwell. And the correction factor given by Maxwell is called displacement current. That is proposed by Maxwell. That is Ampere's circuital theorem is slightly modified by Maxwell with a correction factor displacement current. Third one is d dot dA equal to rho integral rho dV, and in its common form it becomes E dot dA equal to Q by epsilon. Epsilon is capital D, electric flux density. E is the electric field intensity. Therefore, third one is Gauss's law of electrostatics. Total electric flux over a closed surface is 1 by epsilon times the charge enclosed. It is given in the integral form. Charge per unit volume into volume becomes charge. That is d dot dA equal to charge or volume density of charge into volume. Fourth one is Gauss's law of magnetism. These are all Maxwell's electromagnetic equations. Now, in the given question, which of the following equation belongs to the four Maxwell's electromagnetic equations? First one is Faraday's law of electromagnetic induction. It is one among Maxwell's equations. Second one is Gauss's law of electrostatics. That's also included. Third one is B dot dl equal to integral B dot dl equal to mu I. That is Ampere's circuital theorem. It is not taken in the exact form. It is modified with a correction factor. Therefore, here the correct answer is A and B are correct. That is D choice is the correct answer. Now we are moving to question number 6. Which of the following has exactly taken by Maxwell in his four electromagnetic equations without any modification? We have already told Faraday's law of electromagnetic induction. That is exactly taken exactly in the given form. Second one, Ampere's circuital theorem modified with a correction factor. Then Gauss's law of electrostatics, Gauss's law of magnetism. Those two are taken in the exact form. Here the choices are Ampere's circuital theorem. It is accepted but with a correction factor. Then second choice is Ampere's law of magnetic moment. It is not included in Maxwell's equations. Third one, Ampere Laplace law. It is actually Biot-Savart law. It is also not included in Maxwell's equations. Gauss's law of electrostatics. Without any alteration, it was taken by Maxwell. Therefore, which of the following has exactly taken by Maxwell in his four electromagnetic equation? The correct choice is D, that is Gauss's law of electrostatics. Without any alteration, it was taken. Correct answer is D. Now, question number 7. The question is, which of the following does not belong to the electromagnetic spectrum? Electromagnetic spectrum means an orderly arrangement of electromagnetic waves in the order of wavelength or frequencies. And I'll give that arrangement in the order of wavelength. Leftmost, gamma rays, shortest wavelength, then X-rays, then ultraviolet, visible light, infrared, microwave, and radio waves. These are all the members of electromagnetic spectra. An arrangement of electromagnetic waves in the order of wavelength or frequency is called electromagnetic spectra. And the members included in the electromagnetic spectra are gamma rays, X-rays, ultraviolet, visible light, infrared, then microwave, and radio waves. These are all the members of electromagnetic spectrum, or these are all electromagnetic waves. Now the question is, which of the following does not belong to electromagnetic spectrum? Gamma rays, it belongs to electromagnetic spectra, shortest wave with the shortest wavelength. Then second choice, X-rays, it is also an electromagnetic wave. Alpha ray is not an electromagnetic wave. It is one among the radioactive radiations, and it is having 2 unit charge and 2 unit positive charge and 4 unit mass, means it is a heavy particle, does not belong to electromagnetic wave. Then infrared, it is also an electromagnetic wave next to the visible light. Therefore, here the question is, which of the following does not belong to the electromagnetic spectrum? Here the answer is alpha rays. It is not included in the electromagnetic spectra, and alpha rays are one of the radiations of radioactive radiation. It's a radioactive radiation, not an EM wave. Now, question number 8. Which among the following properties satisfied by an electromagnetic wave? First, I will discuss some important properties of electromagnetic waves. An electromagnetic wave consists of electric and magnetic fields perpendicular to each other, and the propagation direction is perpendicular to both the electric and magnetic fields. It does not need a medium for its propagation. Then, it has a velocity 3 into 10 raised to 8 meter per second in air or vacuum. These are all the important properties of electromagnetic waves. Now, here the question is, which among the following properties satisfied by an electromagnetic wave? First choice, it does not need a medium for its propagation. It's correct. Second one, it has a velocity 3 into 10 raised to 8 meter per second in air or vacuum. It is also correct. Third one, alpha ray, beta ray. Alpha rays and beta rays are EM waves. It's totally wrong. The alpha rays, beta rays, and gamma rays are radioactive radiations. Now, A and B are correct. First two choices are correct. Therefore, the correct answer is D. A and B are correct. Question number 9. In an EM wave, then we have to check the choices. In an electromagnetic wave, I have already told electromagnetic wave consists of electric field and magnetic field in perpendicular directions, and the propagation direction is perpendicular to both the electric and magnetic fields. Then, it has a velocity 3 into 10 raised to 8 meter per second in air or vacuum, and it does not need a medium for its propagation. Here the choices are, in an electromagnetic wave, electric field is existing, that's correct. Magnetic field is existing, that's also correct. Both are mutually perpendicular, that's also correct. Therefore, A, B, and C are correct. Here the correct choice is D. This is also about the nature of electromagnetic wave. The question is, direction of propagation of an EM wave is, we have already told the propagation direction is perpendicular to both the electric and magnetic fields. Therefore, the choices are, along the electric field, it is wrong. Along the magnetic field, it is also wrong. Perpendicular to the electric field only, that is wrong. Perpendicular to both the electric and magnetic field. Therefore, The correct choice is perpendicular to both the electric and magnetic field. That is, D choice is the correct answer. Now we have discussed 10 questions from electromagnetic wave. Some equations are there, important standard equations are there, several laws are also included to form the equations. We have discussed in detail a slightly mathematical topic. എന്നാലും ഒന്ന് കൃത്യമായിട്ട് ഈ നോട്ട്സ് ഒന്ന് ആദ്യം നോട്ട്സിലേക്കൂടെ ഒന്ന് പഠിച്ചതിന് ശേഷം ഈ ക്വസ്റ്റ്യൻസ് ഒന്ന് പ്രാക്ടീസ് ചെയ്താൽ ഐ തിങ്ക് യു വിൽ ബി തറോ വിത്ത് ദി ഇലക്ട്രോമാഗ്നറ്റിക് വേവ്. ഇറ്റ്സ് എ വെരി സ്മോൾ സെഷൻ ഇൻ യുവർ സിലബസ്. അതായത് 12th സ്റ്റാൻഡേർഡ് സിലബസിൽ ചെറിയ ഒരു പീരീഡ് മാത്രം ഹാൻഡിൽ ചെയ്യാനുള്ളൊരു കുഞ്ഞ ടോപ്പിക്കാണ്. എൻട്രൻസിന് ഒരു ക്വസ്റ്റ്യൻ പ്രതീക്ഷിക്കാം, ബോർഡ് എക്സാമിനും ഒരു 2 മാർക്കിൻ്റെ ക്വസ്റ്റ്യൻ പ്രതീക്ഷിക്കാം. ഇപ്പം നമ്മൾ 10 ക്വസ്റ്റ്യൻസ് ഡീറ്റെയിൽ ആയിട്ട് ഡിസ്കസ് ചെയ്തിരിക്കുക. പ്ലീസ് ഗോ ത്രൂ ഓൾ ദി ക്വസ്റ്റ്യൻസ്, ദെൻ ഇറ്റ് വിൽ ബി തറോ ഫോർ യു. ഓക്കെ, താങ്ക് യു.